In this video, I'd like to describe breadboards. A breadboard is very useful for prototyping circuits because it allows you to wire up various circuit elements together without doing soldering and without twisting a bunch of wires together. A breadboard consists of a lot of holes into which you can plug various circuit elements. Now, some of these holes are internally connected to one another, and some of them aren't. What's nice about a breadboard is that these plates below the breadboard are all spring-loaded, so if you plug components into it, the pressure against the wires kind of hold the elements in place. Now let's take a look at the internal connections of a breadboard. As you can see, some of the rows of holes in a breadboard are internally connected by these plates, and some of them aren't. If you want to wire things in series, then it's important not to accidentally short-circuit an element. Let's now take a close look at the breadboard and wire up some resistors in series and in parallel so you can get an idea of how easy it is to make some of these connections. As you can see, we've already put some wires into the breadboard in order to connect these two plates with one another, these two plates with one another, and likewise for these two rows up here at the top. The first thing I'd like to do is to wire up these three resistors in series. These resistors are connected at this junction because all 5 holes in this column are connected by a plate inside the breadboard. These two resistors are connected at this junction for the same reason. Let's now wire these 3 resistors in parallel with one another. These resistors are all connected by the plate underneath these holes inside the breadboard. At the other side, they're also connected to one another. I'd now like to wire the resistors up in series again. Let me wire them up and you consider whether I've done it correctly or not. Are these resistors in series or is there a problem? In fact, there's a big problem here because all of these resistors are short-circuited. They're all connected together by the long plate beneath this row. How about this configuration? Are these 3 resistors in series or not? In fact, there's a big problem here as well. These 2 resistors are in series with one another, but this resistor has been short-circuited. Both of its ends are connected by a plate beneath this column. How about this configuration? Are these resistors wired in series, or is there a problem? There's no problem here. These resistors are properly wired in series because this long row is connected by a plate, but it is not connected to the row just next to it. These 3 resistors are properly wired in series. Because I've removed the connections between these 2 plates, I've now allowed this resistor to not be short-circuited. This configuration is wrong. These resistors are not wired in series because this resistor has been short-circuited by a plate that runs underneath this long row. These 2 resistors are in series, and it's as if this resistor is not even in the circuit. How about this configuration? Are these 3 resistors wired in series or not? In fact, they are. There's no problem with this connection. Finally, how about this configuration? Are these 3 resistors wired in series, or is there a problem? There's a major problem here. None of these resistors are connected to one another. These 2 junctions are not connected because the 2 plates run vertically, not horizontally. Let's fix it. There, we fixed that connection. Now we fix that connection as well. These 3 resistors are wired properly in series. There are a couple things to keep in mind if you're going to use a breadboard to prototype circuits. First of all, these holes are rather close to one another, and that means that you don't want to design a circuit that's meant to operate at high voltages with a breadboard. These are very useful for designing low voltage circuits. Secondly, all these plates inside of the breadboard have parasitic capacitances. In other words, plate-to-plate capacitances. You don't want the parasitic capacitances in the breadboard to start to look like real capacitors that you might have spread around your circuit. If you're designing a circuit and your schematic calls for capacitors with any values less than about 100 picofarads, then you shouldn't use a breadboard to build your circuit because that's roughly the same value as the parasitic capacitances that are inside the breadboard already. If you're operating at DC or low frequencies, though, below about 1 megahertz, you're not going to have any trouble using a breadboard, and they're really useful circuit prototyping components. If you enjoyed watching this video, then you might be interested in following our playlist and learning more about the fundamentals of electrical circuits.